Hello and welcome back to Maths with Mitch. Today we're going to continue with our algebra series and look at the rules of indices. So the question on the screen there, a to the power m times a to the power n is question mark. So if you want to find out the answer, you'll have to watch through this video. So firstly, let's start with our notation so that there's no confusion when we talk through the rest of the things in this video. So let's look at a simple term here, 6, and we're going to use a's for the majority of this video, and I'm going to keep that consistent throughout, and then we'll say to the power 3. So we'll use a mixture of algebra and numbers. Previously, we've called this the coefficient, so we're going to continue with that. This here, remember we discussed about this being potentially a variable or a term in algebra. So that's what that letter is representing. But in terms of when we talk about powers, we can also call it the base. So we could refer to that. That variable is a term, but in terms of when it's something to the power, we might refer to it being the base. This then, I've already called it a power. So you could say that. You could say this is a to the power of 3. Or you might hear this called the index, which is where indices comes from, or you might also hear it be called the exponent. So going forward, people might refer to that as a number of different things, but today we're going to mainly be talking about it as a power. I like to use the word power. So firstly, let's look at our first rule of indices, and that is when we multiply two terms together. So if we were to pose the question as we had at the start, a to the power m times a to the power n, what do we do with those terms? So the first rule to learn is that when two times together, the powers add together. So the result is a to the power of m plus n. So if we were to do that with an example in numbers, if we had a to the power 3 and we times it by a to the power 4, our answer would be a to the power of 3 plus 4, which is a to the power of 7. So that is rule number 1. When you times the terms together, the powers add. So rule number 2. What is the opposite of that? And I'm sure if the astute amongst you, you might be able to guess what happens with the indices in this case. That would be easier if I could write it down correctly. So when we divide the terms, we then subtract the powers, and that gives us our answer. So again, if we were to do this in numbers, let's say we have a squared, and we divide it by a to the power of 5, that's going to give us a 2 minus 5, which is a to the power of minus 3. Remembering from when you've done arithmetic and powers in the past, these can be negative. So that is rule 2, when we are dividing one term by another. Now let's move on to number 3. Now number 3, we talked about brackets and what a bracket means in a previous video. So we can have a situation where we have a to the power of m, and that in itself is raised to the power n. So we are then raising that whole term in there, a to the power m, we're raising that to the power of n. And the rule in that case, we times the terms together. So it'll be a to the power of mn. And if you think about what you're doing here, you're doing a to the power of m times a to the power of m times a to the power of m n times. Yeah. So it's timesing the whole term of a to the power of m times by itself, and that's where you get this result. So it's not just a case of adding them together, it's a case of timesing them by the amount of n times. So let's do an example of a to the power of 2. We then cube that whole term. That'll give us a to the power of 2 times 3, which equals a to the power of 6. So you can see there with the examples how to do all three of our core rules, and we're then going to use them to look at the next three. So given that we've now found those three rules for the indices, we can use them to actually find a number of different results. So the first one we're going to look at is the concept that a to the power of 0 equals 1, and in fact any number to the power of 0 equals 1. So a couple of things of why that might be true, as you might assume that it's actually equal to 0. But if we look back at our rules there, and let's think about this in terms of a to the power of m, and if we divide it by a to the power of m, if we follow our rule here, if we divide it, then you would minus the powers, so that would be a to the power of m minus m, so that would be equal to a naught. But also when we think about numbers in arithmetic, anything divided by itself ends up as 1. So what you can say is this statement here equals 1, therefore a to the power of 0 must equal 1. And that'll be true for every single number. So anything to the power of 0 is equal to 1. So if we just make ourselves a little bit of space here. So let's add that now here to our rule. A to the 0 equals 1. And a can be any number. Anything to 0 is 1. Now next, I want to consider negative powers. So let's have the situation here where we have a to the m, and we're going to divide it by a to the n. Now we've just said the rule is a m minus n. So let's put some numbers in, and let's say m is equal to 2, and n is equal to 6. So that gives us a to the power of minus 4. But what we can also do is write it, if we were to consider it in its long form, we've got an a times an a, and we're divided by 6 a's on the bottom. And now let's cancel them. So we could cancel 2 from the top, 2 from the bottom. That is mathematically correct. And then we'll be left with just 1 on the top. So that would leave us with 1 over, and then we have 1, 2, 3, 4 a's left. So 1 over 4. So we've written that in two different ways, but we've done the same maths on it. We've done a squared divided by a to the power of 6. So what we can now say is that, having done that in both those ways, mathematically these are the same thing. When you have a negative power, what you are also saying is that it's 1 over the positive power. So we're going to have that as rule number 5. We're going to say a to the power of negative m is the same as 1 over a to the power of m. Now the last thing that we can do using the rules of indices is to consider a square root. So let's think about it in terms of a number first. So let's think 25, the square root of 25 equals 5. Now another thing if I was to represent this as x, then 25 is 5 squared, is x squared. So what I could say was x squared, which is 25, and then the root of x squared, and that would be equal to x. So that is the same thing written in terms of algebra as we've got in the numbers above. So if we square root something that's to the power 2, we get back to the original term. And that technically is x to the power of 1. But we've just said, if we look at rule 3 here, that if we have something in brackets and then we raise something else to the power, we times the powers together. So we could say here x squared times something is x to the power of 1, and we can try and find out what this something is. So we've just said, rule 3 here, we times it by something to get to here. So 2 times an unknown, let's call our unknown a, equals 1. So we can divide by 2 on each side. And we can say A is equal to 1 over 2, a half. So we're saying here that this is a half. Therefore, what we've shown there is if you square root something, that is the same as timesing it by a bracket and raising it to the power of half. So we can therefore say that the square root of x is equal to x raised to the power a half. So we can say that a root is the same as a fractional power, and we can have that as a generalized rule and say that if we have a to the power of a fraction, that 1 over m, that is the same as the root of a to the power m. So that is the rules of indices, the first 3 rules, and then from that we can get the following 3 results that come from that. So that's everything you're going to need to know to manipulate algebra and indices and take them further into your studies. So I've been Mitch, thanks for watching, subscribe to the channel.